In an earlier video, we talked about using p-values to make a dichotomous decision. Either you reject or fail to reject the null hypothesis. But of course, if you're turning it into something concrete like that, it's always possible that you could make the wrong decision. So this video is about the two different ways that that can go wrong, and they are creatively named type 1 and type 2 errors. So let's say that the null hypothesis is actually true. In that case, the correct decision would be to fail to reject the null hypothesis. Right? That's what you would hope the data would lead you to. But it's possible that you would reject the null hypothesis when the null hypothesis is really true. This is called a type 1 error. So it's called an error, but it doesn't mean that you did something wrong. It just means that because of sampling variability, the particular sample that you were working with led you to an incorrect decision. So that's a type 1 error. We also sometimes think of a type 1 error as like a false alarm. So really the null hypothesis is true. There's sort of nothing going on, but the test tells us that there is, right? The test gives us like a false positive or a false alarm. The other situation is where the null hypothesis is actually false. In this case, the correct decision is to reject it, right? We want to reject the null hypothesis when it's false. But it's possible that we will come to the wrong decision. Again, not because we did anything wrong, just because the data leads us to the wrong decision. And in this case, where we fail to reject the null hypothesis when it's actually false, that's called a type 2 error. Sometimes you think about this as like a missed opportunity, right? There really was something going on in the data, but you weren't able to detect it. That's a type 2 error. So some people like this table, some people like it in sentence form, so I'm going to write it both ways. A type 1 error occurs when researchers reject the null hypothesis, when in reality, the null hypothesis is true. A type 2 error occurs when researchers fail to reject the null hypothesis, when in reality, the null hypothesis is actually false. So in that case, the alternative is actually true. So some people like to remember that the errors are named after the hypothesis that's actually true. So if the first hypothesis you write down, the null, is actually true, then that can be a type 1 error. Whereas if the alternative is actually true, the second one that you write down, that's a type 2 error. Other people like to think about the story of a boy who cried wolf because it's sort of like a type 1 and a type 2 error in that order. So assuming that the null hypothesis is no wolf, as it pretty much always is, then at first the boy is crying wolf when there really is no wolf, right? And the people believe him, so that would be a type 1 error. And then later in the story, there really is a wolf, right? So the null hypothesis of no wolf is actually false. But people don't believe it, right? They don't come to that conclusion. So that would be a type 2 error. But let's think about type 1 and type 2 error in a more serious context. So let's go back to the example about St. George's. In section 1.2, we used a sample of 361 heart transplants to test whether the heart transplant death rate at St. George's is higher than the national average of 15%. So in this example, the null hypothesis is that the rate is actually 15%, right? That St. George's is the same as the national average. And the alternative is that it's greater than 15%, right? That for one reason or another, the death rate at St. George's is actually higher than average. So what would a type 1 error be in this context? So a type 1 error occurs when researchers reject the null hypothesis. So in this context, that would mean that we believe that the death rate is really higher than 15%, right? We reject the null and we believe the death rate is higher than 15%, when in reality, the null hypothesis is true. So we think it's higher than 15%, but really it's equal to 15%. So what are the real world consequences of making that kind of error, right? If you think that the death rate is actually higher than average, but in reality, it isn't. The consequences of that is that whatever kind of follow-up you were doing would cost time and money, right? So your time and money would be wasted on a follow-up investigation. So that kind of fits with our interpretation as a false alarm, right? That there really wasn't anything wrong at St. George's. It was just a false alarm. And so we wasted this time and money following up. What about the consequences of a type 2 error? So a type 2 error occurs when researchers fail to reject the null hypothesis. So in that case, it would be saying that we believe that the death rate is 15%, or at the very least, we think that that's a reasonable value for the death rate at St. George's, but really, it's higher. Right? So you can think this is like a missed opportunity to improve things, right? It actually is higher than 15%, but we were unable to detect that. So you can see how this could be dangerous in this context, right? If there were potential problems, which maybe or maybe not, it's hard to say why it would be higher at this hospital, but potential problems could go undetected and uncorrected. So that's our concern if we make a type 2 error in this situation. So remember, the purpose of our significance level is to decide how small a p-value needs to be before we're willing to reject the null hypothesis. So by setting the significance level, we change the likelihood of rejecting and failing to reject, and we also change the likelihood of making type 1 and type 2 errors. So as we're setting our significance level, it's really important to think about type 1 and type 2 errors and which of those would lead to more severe consequences. So that's what you're going to think about in the next activity.